Hello, this is Dr. Mears, and today we are going to be learning about geometric series. First, I do want to make note of my new reference on the bottom of the pages. I am getting all of these examples from the Mathematics Applications and Interpretations S standard level from Oxford University Press by Belcher and many other brilliant mathematicians. It was copywritten in 2019. So you're going to see this reference at the bottom of the page when I do use their work. I feel that I should be giving them credit because I don't make up some of the problems. So when I use their work, they are going to be getting their due credit. Some problems I do make up, some I don't. So if I use even one piece of their work, you will see a reference at the end of the page. So that's what's new for me. All right, so let's learn about geometric series. To find the sum of n terms of a finite geometric series, we're going to be using this formula. Now, finite means that the pattern stops. So they might say the first 6 or the first 8 terms. So we know that it has a stopping point. All right, let's dissect the formula and label it. S is going to be the sum. That's where we would add them all together. N is going to be the nth term. So that's going to be how many we have, how many they want. So they might say the 8 terms or 7 terms or 20 terms. U1 is going to be our first term, as always. Our N, right here, again, means the nth term. So these should be the same number, these two N's. Our R is our common ratio. And again, down here, same thing, common ratio. Oops, not ration, ratio. And it's going to be subtracted from 1 here and here. And I'm going to show you a little hint just to make sure that you're checking everything. So the two N's should be the same here. These two R's, they should be the same numbers, and it should be -1 both places. Now, where R does not equal 1, here's the thing. R cannot be 1. If we have 1 in the denominator, we can't find an answer. It does not exist. So R can't be 1. Denominator would be 0. An example of that is just something, let's say that we have 4 over 1 minus 1. I simplified the top, let's just say. I'm just giving you an example of what happens. So we would have 4 over 0. Now, if we try to do that in our calculator, 4 divided by 0, oops, lots of stuff. I'm just doing 4 divided by 0. Look what happens. We have an error. We can't divide by 0. There is no number. So there is no number. So that's empty. Nothing exists. So it's going to cause you an error. Okay, so that's why they have that stipulation there. All right, so let's use our formula to find the sum of a geometric series. Here's our examples. Number 1, find the sum to the 8 terms of the geometric series 7, 28, 112, 448, and as you see, it keeps going. Okay, well, let's reread it again. Find the sum. So this means that they're going to want you to find S. Okay, 8 terms, so that means N is 8. So we could keep going in our pattern, everybody, till we have 8 terms, so we could get to U sub 8. We have U sub 1 here, which is going to be our 7. So we could get to U sub 8 and then add them all up. I'm not going to do that. If you haven't seen my arithmetic sequence and arithmetic series videos, look those up, and I do extend the pattern and I do show you the long way. But because we are on geometric, hopefully you've learned about arithmetic. So if we went to U sub 8, we could add all of these up. I'm going to use the formula. So let's start filling things in. I don't have my sum. That's what I'm looking for. I'm looking for 8 terms. That's going to equal. I need my U sub 1. U sub 1 is the first term, so I just labeled that. That's 7 times. I need my R. R is common ratio. So let's go find R. Okay, remember, R can be found. I'm going to label these U2, U3, U4. Okay, our common ratio here can be found by taking the second term and dividing it by my first. Please be careful. It's always this second term divided by the first. So R is going to be 28 divided by 7. 28 divided by 7 is 4. So we have our R. Okay, coming back over here. Nope, not R, everybody. Write a 4, please. 4, and then it's going to be raised to the nth term here. What's my nth term? Oh, that was 8. So these two numbers here should be the same. Okay, what's next? Minus 1. All over R, again, here's my R, that number right there, 4 minus 1. So these two numbers here should be the same. 4 and 4, these two numbers, 8 and 8, and then I shall always minus 1, minus 1. And that's how you can quickly check that you put the numbers in correctly. Okay, now it's the calculator's turn to do some work. What I like to do is I like to simplify this 4 minus 1. So I'll rewrite this over, and instead of 4 minus 1, I'll write 3. I like to do that. I don't like to do it all out in the calculator. It can get pretty confusing with parentheses and everything. So you can subtract 1 quickly and just get 3. So now we can put this whole thing in the calculator. We can do 7 parentheses, 4. Remember, this is your exponent button. Right underneath this clear button is your exponent right here. So raised to the 8. Remember, if your calculator looks like this, you might have a little arrow button. That means that you're still in that exponent spot. So you're going to have to press this right arrow button. So press this right arrow button and it moves you away from that exponent. And then we could do minus 1. So just make sure this minus 1 is not by that 8. That's a very common mistake. So you have to be diligent in this, or you will get the wrong answer. Close your parentheses. Please remember, close your parentheses because I want to divide that whole thing by 3. And I get 152,915. There we go. So if I went to this 8th term here, all the way, I don't know what it is, we don't need it, but if I went there and I added all of them up, my sum would be 152,915. So we found the sum of the first 8 terms. Yay. Okay. Next, example number 2. If I could. There we go. Okay. When Kenzo started Bright Academy, the school fees were yen 2,500,000. And that's Japanese yen, and these are the letters that they actually use, JYN, which is pretty cool. You're going to learn about lots of different currencies and how they are represented in this course. One of my reasons I really like this course. The fees increased by 2% each year, so they increased by 2%. Kenzo attends a school for a total of 6 years. Okay, we're getting some, you can see where I'm going with this because we're getting a couple of the variables that we need. So when he started, the fees were 2,500,000. So yes, you know that's U sub 1. We have a total of 6 years. That is going to be our N. Now be careful because we're dealing with percentages. So this isn't our common ratio yet. This is just our rate. And it's actually in a percentage. So we have to write down the common ratio for part A. So don't automatically, do not write this down. So because we are increasing, to find our common ratio, what we have to do is we have to do 1 plus our rate, but we have to make sure that it's in decimal form. That's how you find if you're increasing by a percentage. So let's change this percentage. We know how to do that. We're going to do 2 divided by 100 equals 0.02. So that's basically your first step. Number 1 is to change that percent to a decimal. Okay. Now to find my common ratio, known as R, I'm going to do 1 plus 0.02. So 1 plus my rate as a decimal. So my common ratio is 1.02. Now that's for increasing, okay? The decreasing, I'm just going to do a side note here. I know that we don't have decreasing, but you might see it on some papers. So decreasing, to find our common ratio, would be 1 minus our rate as a decimal. Okay, that's kind of squished, sorry. I wanted to do it on the side a little bit. So our common ratio, so R would equal 1 minus the rate as a decimal. I just rewrote it for you nice and neat right here. So if you want to write that one down, okay? So increasing, we have to add 1 to the decimal. Decreasing, we'd have to subtract 1 from the decimal. All right, so we got our right here. Because we're increasing, there's our common ratio. Let's now do part B, calculate the school fees in year 6. Okay, they say nothing about sum. They say nothing about adding them up. So what they want us to do is go back to our original formula. They want to know how much in year 6. So this goes back to u sub n equals u sub 1 times r to the n minus 1. All right, so how many years? N is 6. So u sub 6 equals, what's my starting amount? I labeled that up here, 2500000. Now notice they don't use commas, they use spaces. I really like the spaces because it helps you to write the numbers down more easily and to see how many zeros there are. So I really like that they use their spaces. So instead of commas, they use spaces. Just more you know. Okay, so here's our first term times our R, which was 1.02, raised to the n is 6 minus 1. And we could do that in the calculator very simply. Bring this over, turn it on. So we have 2 and then 500, 1, 2, 3. See how easy that was with the spaces? I really like that. Times 1.02, exponent button, everybody. 6 minus 1. And you want to keep that minus 1 up near the 6 in the exponent spot. So keep that there. That's part of the exponent, everybody. All right, press enter. And we get 2760202. I'm just going to round it to the nearest yen, making sure 2760202. Yes. Okay, and you know, I really like you to start writing complete sentences. So the school fees in year 6 are JYN, and then let's see, it would be 2 space 760 space 202. So I just kind of put my spaces in there, which was pretty nice. Okay. All right, next and lastly, part C, calculate the total fees paid for the 6 years that Kenzo attends Bright Academy. All right, total fees paid. So yes, we're in sum. Yes, we are in year 6. So we are looking for our sum formula. So S sub n equals U sub 1, R to the n, and then minus 1, all divided by R minus 1. These formulas, this formula and this formula, this is going to be given to you in a formula packet that you can use on any IB test, which is great. So you will have these formulas, so please don't think you're going to have to memorize them. You're not. It's really how you use them and how you understand where the numbers go and what you're finding. Here we're finding the total fees. Okay, let's substitute some of this in. I'm just going to substitute over here. Gives me a little bit more room. So Sn is 6 equals U sub 1. So let's go back. Remember, our U sub 1 is the original amount. That's why I label it. I love labeling. So 2500000 times our R. Our R is going to be 1.02 raised to that 6th power minus 1. Remember, that's not in that exponent. It's below now. It's different than this. So this minus 1 is in the exponent spot. This is not. All divided by 1.02. minus 1. So I like to check 6 and 6, perfect, same number. 1.02, 1.02, minus 1, minus 1. All right, everything's good. I just checked my numbers out. All right, so S of 6 equals, I'm going to subtract that. So I'm just going to rewrite the top because I'm going to do that in the calculator. All divided by, and then my 1.02 minus 1 is 0.02. So that gets us back to kind of our original 0.02% as a decimal. Okay, so then S sub 6 equals, let's see what this equals. 2, 5, 0, 0, 1, 2, 3, 1.02 raised to that 6th power, get out of that exponent spot, minus 1. Okay, and, oh, I was going to do it all in one step, but divided by 0.02 is 15770,302. Perfect. You could do this all in one step where you did divided by 0.02 there. So you're either way you want to do it, you're fine. Sometimes I press enter by accident, but then I just divide. So you will get the same answer if you did it all in one step. So total fees paid for 6 years is JYN, 15770,302. Wow. My wonder for this is how many US dollars that would be. That would be interesting. Okay, this has been Dr. Mears' geometric series of finite patterns for geometric sequences, and I hope it helped. Thanks.